In this video, we'll be finding the domain and range of a trig function. Our problem is to find the domain and range of f of t is equal to cosecant of pi t over 2. Now we know that the cosecant is the reciprocal of sine. So the cosecant is undefined when the sine is equal to 0. Sine theta is equal to 0 when theta is equal to 0, pi, 2 pi, and so on. So for our function, we need to use just our argument here, pi t over 2. So pi t over 2 cannot equal 0, pi, 2 pi, and so on. Because if it is, then the sine will be 0 and the cosecant will be undefined. Now what we need to do then is solve this equation for values of t. So let's go through and multiply both sides of the equation by 2 over pi. And we can see on the left side that our 2's will cancel and the pi's will cancel. And I'll have t cannot equal 0 times 2 over pi is 0. Pi times 2 over pi, the pi's will cancel, and I have 2. 2 pi times 2 over pi, again the pi's cancel, and I have 4. And it looks like we have t cannot be equal to all of our even integers. Now the way to guarantee that we have an even integer is to write t cannot equal 2n for n element of the set of integers. So if we wrote this in set notation, we would say our domain is equal to the set of all t's such that t is not equal to 2n and an element of the set of integers. Now, we also are asked to find the range. Our cosecant curve, again, is the reciprocal of sine, and if we were going to look at the graph of the sine curve, we know that the max is reached at +1 and the min at -1. Now the amplitude of the sine curve is designated with the coefficient in front of the trig function. So in this case, we're still dealing with a sine curve that has an amplitude of 1. So that means then that our cosecant curve is going to look something like this. And all of this space in between here, in between 1 and -1, is empty. So our range is going to be all real numbers from -infinity up to -1, and then we skip over this empty space and pick it back up at 1 and go on up to +infinity. So we would show that with interval notation. We're going from negative infinity to -1, and we include the -1 because the reciprocal of -1 is -1. Union with, and then when we pick it back up, we start at 1 and go to positive infinity. So our answers to this problem: